Welcome to 2026, where the cloud is no longer the default. We are witnessing a massive shift to 70 billion parameter language models run portably on consumer hardware. From Apple's M5 Pro to Qualcomm's Snapdragon X Elite, the hardware bottleneck has been shattered. Today, we are diving deep into the developer's guide for NPUs, edge inference, and the frameworks making local AI a reality.
The performance metrics in 2026 are staggering. Apple's M5 Max provides up to 614 gigabytes per second of memory bandwidth, making it a genuine competitor to cloud endpoints. Meanwhile, dedicated NPUs are reducing matrix vector multiplication latency by over 58% compared to traditional GPUs. This isn't just a marginal gain, it is a fundamental architectural shift in how we process intelligence at the edge. Understanding the compute triangle is essential for any AI developer. The NPU is your specialist for the decode phase, handling the sequential generation of tokens with minimal power. The GPU remains the powerhouse for the prefill phase, where parallel processing of long context prompts is required. Finally, the CPU serves as the universal fallback for smaller models under 3 billion parameters, where power efficiency is the priority. Apple's M5 chip represents a paradigm shift. By embedding neural accelerators directly into every GPU core, the distinction between the GPU and neural engine is collapsing. This architecture allows the processors to cooperate on inference tasks rather than competing for resources. This is why we see a 4x jump in LLM performance on M5 compared to the M4, driven by architectural synergy rather than just raw TOPS. For developers on macOS, MLX is the definitive framework. It is built specifically for unified memory and consistently outperforms llama.cpp on models under 14 billion parameters. Converting a Hugging Face model to MLX format and running a 4-bit quantized inference is now a streamlined process that can be handled entirely within a Python environment, enabling rapid local prototyping and deployment. On the Windows side, the Qualcomm Snapdragon X Elite is the primary target. By using the ONNX runtime with the QNN execution provider, developers can tap directly into the 45 TOPS NPU. This allows for high-performance inference on Windows Copilot Plus PCs. The implementation requires specifying the QNN backend path to ensure the workload is offloaded from the CPU to the dedicated neural hardware. Llama has simplified the local inference layer to the point of being the industry standard. With over 90,000 GitHub stars, it allows developers to pull and run quantized models with a single command. By serving an OpenAI-compatible endpoint at localhost, Llama makes it trivial to swap cloud-based LLM calls for local ones without changing your application's core logic. When choosing hardware for your 2026 deployment, memory bandwidth is the metric that matters most. The M5 Max is the king of large models, supporting 70B plus parameters. The M5 Pro is the sweet spot for mid-range models, between 14B and 30B. For smaller, app-embedded models, the base M5 or the Snapdragon X Elite provide more than enough power for deterministic, low-latency performance. The software ecosystem is maturing rapidly. Apple's preview of Core AI for iOS 27 and macOS 27 aims to unify on-device and hosted models under a single API. This means developers can write code once and let the OS decide whether to run the model locally on the NPU or hit a private cloud endpoint, depending on the device's current thermal and battery state. For production-grade deployment, quantization is no longer optional. Moving to 4-bit quantization allows you to run massive models on consumer-grade memory without a significant loss in reasoning capabilities. By combining quantization with NPU-specific execution providers, you can deliver a user experience that is faster, cheaper, and more private than any cloud-based alternative available today. The verdict for 2026 is clear. The edge is where the innovation is happening. With the collapse of the NPU-GPU divide and the rise of high-bandwidth unified memory, the local machine is now a powerhouse for generative AI. Developers who master these local frameworks today will be the ones building the private, secure, and lightning-fast applications of tomorrow. Ready to stop paying cloud bills and start building for the edge? The revolution in on-device AI is just beginning, and the tools are ready for you. For the full technical breakdown, code samples, and hardware benchmarks, visit Effloow.com and join the next generation of AI developers.